Okay, so let's get started. We're going to be taking a look at working with our drive-by-wire throttle control. Once again, this training module, we're going to be doing an overview of the tables that we have to work with to program the feel of our drive-by-wire actual operation on our engine. And we're also going to take a look at a couple limit tables that we have to work with to be able to limit throttle in various different conditions or programming strategies that we have within our Motec. Let's jump in and take a look at what tables we have available and how the tables actually are going to work in terms of our pedal to plate relationship in drive-by-wire control. So we're going to move from our tuning area here and jump over under setup and move across here under our window throttle servo. This is where we spent the majority of our time in that last training module. Now at this point, we've configured the Excel pedal position sensors. We know they're working between 0 to 100%. We can see that right here expressed as throttle percent. We can see right now our throttle pedal sensor, that's the actual values that it can see. It moves in 0 to 100. That translates to a throttle pedal. There's a way we can change this relationship. We'll talk about that in the training module here. And then we also have both the position and the aim. The aim is our desired target that's coming from the throttle area table here. We'll discuss how that works. And then the position is going to be what we have as our corrected position. Now these two are tracking together properly because we have our PID control and feed forward table values populated down here under our throttle servo bank 1 output. So we've configured all of this. We talked about how to do that in that last training module. So at this point, we have a fully functioning drive-by-wire control system. Let's jump in and take a look at what we have in terms of our two primary tables for changing the relationship between our pedal and our plate. We'll find that when we're talking about a cable-driven mechanical-based throttle body, we have a throttle linkage, we have a throttle cable. If we give 5 or 10% movement on our actual pedal assembly in the vehicle, the gas pedal, which is connected to the linkage, which is connected to the throttle body, we'll find that the throttle plate will move that 5 or 10%. So they're moving at a 1-to-1 linear fashion. In drive-by-wire, we can change that pedal-plate relationship, which can really change the drivability of our vehicle with a really large throttle body. Or we can change the response of our pedal feel by having, let's say, 20% pedal movement gives you 50% plate movement. It can really change the driving feel or characteristics of your vehicle. So we have a lot of programming flexibility in how we can accomplish this. And the two tables that are working together are going to be our throttle area percent and our pedal translation table. Now, the way that we've configured this in our last training module is we've set our throttle area percent into a linear fashion. So 0 on our throttle servo position, that's our throttle blade opening, that's going to be 0 in our throttle area percent. And then if we go all the way across here, 100 is 100. And note that every single point below, so the break point of our throttle plate, is going to correlate to our throttle area percent. This table is going to effectively represent the effective area of our throttle blade. The effective area is going to represent the flow or nonlinear flow we have coming into our throttle plate. So when we're talking about a throttle body, and we're talking about various different servo position openings, so throttle blade openings, we'll find that the effective area or the flow ratio coming across our throttle blade won't be exactly linear. Typically speaking, if we're in a small throttle body, we're going to find our values here are going to be more linear to each other. But on a really big throttle body, we're going to find that we're going to have an unlinear relationship. So something like 16% throttle blade opening on a 120 millimeter throttle body won't be 16% of our effective area or flow across a throttle blade. You may find this at something like 30% effective area or flow across the throttle blade. Now the values in this table are going to be specific to the throttle body you're working with. We can determine the values either by having Motec give us this information if you have a throttle body that's been characterized from Motec, or if you have a flow bench and you can actually flow your throttle body opening at various different throttle servo positions, you can determine the values in our table here. So what you would have to do is obviously 0 throttle area, effective area, it's our throttle blade closed, that would have 0. So 0, 0. So throttle plate closed, 0 effective area. 100 right here, 100% throttle blade opening, you would flow that, and that would be your maximum CFM you'd measure on a flow bench. So we would know whatever that value is. Let's just keep it simple here. Let's say it was 1,000 CFM. You would then move into your various different throttle positions here. So 80, let's say 60, we would do one at 40. And what you could do here is at these various throttle blade openings, you could actually measure what your CFM is coming from across your throttle body. And by knowing the relationship of your flow at this throttle angle versus your maximum flow, you can determine the actual percentage that you would populate in here. That percentage of throttle area, that would be essentially percentage of your flow. What this table does is turn a non-linear relationship between throttle blade and airflow into a linear type of fashion. So when we command, let's just say 30% of our pedal to 30% of our throttle blade opening, what that's going to do here is look at the normalized value and give us 30% of the flow, not 30% of the throttle plate opening.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.